All right. So we're going to be looking at this sine or cosine curve. We're going to take the route less traveled, okay? As in, if it looks like if it'd be easier to do a cosine curve, then we'll do a cosine curve. If it looked like we don't have to shift it and get a sine curve, then that's what we're going to do. So you want to take the easiest way to do it. You know from last class we could do both, right? And we will, but just not right. So in your opinion, Aaliyah, what would you like to call this, cosine or sine? I think you're smart. Okay. So it's a cosine. Did somebody have a question? Yes.
I'm going to ask if it's be a negative cosine.
Yes, this is definitely a negative cosine curve because it starts down. Okay? So down and it ends down. This is one cycle. Okay? Now again, just like you had to know how to graph one cycle, you have to recognize the cycle as well. Yes? Yeah, but it's easier to do a negative cosine than a sine curve shifted. Yes, ma'am. Okay. Now remember the amplitude is how tall this thing is. It is half the difference of the range. Okay, so what's my range? It's not 5, it's 4. And it's not 5, it's -4. So yes, I heard somebody say it's 8 tall, so half of that would be 4. So my amplitude is 2. My A is 2. So far, we have y equals, I don't know. Good Lord. Good Lord. Thank you. All right. 4 sine, cosine, -4 cosine. Wow. Okay, so far so good. We're ready for B. Okay. Or actually, I always find D next because it kind of goes along with A. All right, so that's why it's in this order. The D is the middle. And technically, middle, what's another word for middle? Starts with A. Average. How do you find the average of two things? You add them up and divide by how many. In this case, we're going to add up 4 and -4 and divide by 2. And what is that? 0. So there is no D there. So C, 0 goes right there. Okay? Any questions about that? So this is pretty methodical if you want to be. If you want to think about it, you could also do that for those of you that like to think instead of doing things the same way all the time. Unlike me. Okay. Period is your next thing we're going to do. Okay. Looks to me that we started at 0, one cycle, we ended at 2 pi. Sometimes that's hard to ascertain, but that's clear. Okay. So my cycle, my period, is 2 pi, but that doesn't make my B. That's just where we find it. What's the relationship between period and B again? 2 pi over B. Okay, so we're backwards from where we did before, but the period we said was 2 pi. 2 pi equals 2 pi over B. What's B? Good. Okay, and just sometimes this is a lot more difficult, but most of the time you can look at it and say, oh, that's going to be 4. Oh, that's going to be 2. So this is 1. Okay? Again, you can leave that 1 off just like you can leave this off. All right? It's the simplest way in a minute. Okay. Find the horizontal shift, which is the C. Okay. The horizontal shift is where a cycle starts. Okay? Where does this one start? Starts right where it's supposed to start, right? So what's the horizontal shift? 0. Okay. Now, there's a lot of extra in here. What's the easiest way to write this equation? -4 cosine x. Good job. Okay? Now, let's do what a suggestion. Let's do a sine function just for fun. Okay. A lot of times I'm going to dictate that I'd rather have a cosine or sine. The test sometimes will let you decide, but for the most part, there's a clear choice. That's your choice because there's no shift. It makes it a lot easier. Okay. This time we're going to do a sine curve. All right, in blue. All the green was okay. So my sine curve, I can start here and go down. That's a negative sine curve. Or I can start here and go up. What do you want to do? Start where, Claire? Negative or positive? If you want to start here, I'd rather do the same. Okay, so that's what we're doing. Claire decided. I agree. Decision made. Okay, so this is my sine cycle. All right, so that's the first thing. Of course, your A is going to be the same. Okay, we have a positive sign. A is 4. Vertical shift. Now, we didn't have a vertical shift before. We're not going to have a vertical shift now. All right, the middle is still going to be found the same way. Okay, my period is going to be the same. Gosh, sakes. Am I doing this today? Thank you for correcting me. Okay, it equals 1. Okay, now we did shift it, didn't we, horizontally? We said, wait, it's not starting at 0. A regular sine function starts at 0. We didn't start at 0, so now we got to figure out what this is because it's not identified. We can figure it out from the spacing on the 2 pi. What is it? Pi over 2. Very good. So C is pi over 2. Okay. So 4 sine x minus pi over 2 is our sine function. You put those in your calculator, y1, y2, they just roll the same way. Okay? And they would look like that. Okay? If we decided yet again to do the negative sign, that would be this one. We're going to start, what do you think that is? Negative half pi. So the difference would be this. Okay? So all those are the same thing. Go the easiest route if you have a choice. If you don't have to shift it, that C makes everything more difficult. Not everything, but the main thing. Okay? The B, the D, and the A are all the same, but the C creates another. Just think about when you're graphing. If you don't start at 0, that C messes things up a little bit because you got to do different things. Any questions? Yes. I would probably tell you to, yes, I would. If I didn't dictate, I want a cosine curve. Yes, I would. I would accept any of those. Good question. Okay. All right. Let us do another simple one. Okay. All right. Now, again, you're looking at the axes. Do you think you want to call this a sine or cosine? Lizzie. Sine? Or no, cosine? I think cosine's easier because if you, even when you put in the middle here, you're going to start at the top. So I think cosine will be easier. All right? So let's find the amplitude by identifying the top, which is 1, the bottom, which is -3. So 1 minus a -3 divided by 2 is what? 2. So the middle is 2. How can that be?
No, it's right. D is the middle.
I know, but the middle's up here. I don't think so.
-3 minus.
Oh, stupid me. I'm finding the middle down here.
Yeah.
Sorry, that's not the middle, that's the amplitude. Oh, goodness. Okay, that's not the middle. Okay, the middle is the average. All right, so that's your amplitude, so it's too tall. What's the middle? Negative what? Negative 1. Okay, which makes sense. All right, there's your middle. Up to, down to, that should all work. So your D is negative 1. So you subtract them to get the amplitude, you add them to get your middle average. Try to make sure that makes sense to you, because otherwise you could get them confused, just like I did. When we went back to make sense, that didn't make sense that was the middle. So that's how we knew that, once again, I had made a mistake today. All right, so the period. Good boy. Okay, so identify a cycle. It looks like this is the beginning of the cycle, end is right here. And middle is dead center. Pi, it looks like. Or not, because, yeah, it looks like pi is the middle, doesn't it? Because it's all the way down. So from 0 to pi, then from pi to, what would this be? Oh, gosh, okay. On my red. Okay, so what's this? 2 pi over 3. Okay, good job. My red line covered it up. Okay, so my period is 2 pi over 3. Okay, and my period equals 2 pi over b. So b is clearly 3. Okay, I'm sure I just changed colors, but anyway. All right, my horizontal shift. The reason we chose cosine is so it didn't have a horizontal shift. So C equals 0. All right. What's my equation, Miss Connie? Oh, sorry. Very good. Okay. So you just have to pick out one cycle, find the top, find the bottom, find the middle, find the B. If you choose wisely, maybe there wouldn't be a C. Yes, ma'am?
It's when they got the negative 1.
Yes, I took the average of the top and the bottom because that's the middle. The D is the middle.
Oh, I did not know. I did it for me.
Oh, okay. Yeah, you take the average, and here you take half of the difference. So this is half of the difference, this is half of the sum. If you want to remember it like that. Again, try and have it make sense. The D is your middle, and your amplitude is right there. And the C is where you start. Okay? We won't do a sign, but know that we could if we wanted to, or not take the time. Any questions before we go to the next? Okay, I think we're ready for some good application. Plural application. All right, we're in good shape. Okay. A one-line highway runs through a tunnel in the shape of 1/2 of a sine curve cycle. There it is. Here's your sine curve, half of it. The rest is underneath like that. Okay. All right. The opening is 28 feet at road level. What's 28 feet? Where do I identify that? Right here? Okay, so that's 28 feet. All right, good work. And is 15 tall at its highest. So this is 15 feet tall. Okay? All right, find an equation for the sine curve. So we don't have to decide. They already said it was kind of a half a sine anyway, so that would have been a not really a obvious thing. That fits the opening. Place the origin at the left end of the sine curve. Okay? Left end of the sine curve would make the origin right here. There's your origin. Okay? I don't think we're going to round. We're just probably going to keep it exact. All right. So far, what's my A, Lydia?
15.
15, good job. That's how tall that thing is. There's nothing to figure. That's what A means. Good job. All right, B is my period. Ish, involves my period, I should say. Okay, what is my period? 56, who said it? Kara, where'd you 56? Nice. Remember, there's 28, half of it, the other half is 28 as well. Good job. So 2 pi over 56, we'll just leave that as pi over 28 when we reduce it, instead of doing decimals. Okay, good work. All right, going right down the list. C, what's C again? The horizontal shift. We aren't shifting, it said to put that origin right there, which was nice and convenient. And then D is the middle. We're assuming it's at road level is the y-axis, so D is also 0. Because that's our origin, it's not really an assumption. That's our origin, that's 0, 0. Okay? So we have a sine curve. What is it? Lena.
15 sine 2, pi over 28.
Okay, I don't need the parentheses, but. Okay, very good. Okay. All right. So here's a little application. If the road is 14 feet wide, that's why you need your civil engineers that do roads and bridges and such. They need to be good math people. That's exactly where some of these equations come from, this sine curve, or the cosine curve, or some polynomial curve. If the road is 14 feet wide with 7-foot shoulders on each side. Okay, so this is your, remember there's a road in here, and then there's a shoulder. Okay, let me just reproduce that here. All right, it's road is 14 feet, 7 feet, and then another 7-foot shoulder. 7, 14, 7, that makes up 28, right? Okay, what is the height of the tunnel at the edge of the road? So we are looking for, here's my road. At the edge of the road, we're looking for this, which is also the same as this, symmetrically. Okay? So how to do that? Got an equation for the curve, right? So what do we do? What do we know? Claire? Yes, ma'am. Let x equals 7. Now this is probably where we want the 3 digits here. Okay, now no one would expect you to know what that is without a calculator, so you throw it in the calculator. Maybe? Yes. And round is to 3 digits, 3 decimals. You don't have to put it in your equation, you can just do it just like this in the home screen. 15. And remember, mode should now be pretty much all the time on radians unless you're checking something out. Anytime you're graphing trig, it's got to be on radians. 15 sine of, I'm going to make my good fraction here, pi over 28, close my parentheses, times 7. Okay? Am I taking, yeah, that shouldn't matter if I have parentheses or not. 15, hold up. Yeah, I think I did it backwards. Hold up. I over 28 times 7. Oopsie, not there. Times 7. Is that what I want? You see the difference, though?
Oh, wait, why would you put it inside the parentheses?
I don't know. That's what we got to decide here, Rachel. Which one is right? Is x, if you were doing just make this is technically C, right? Does that change? Should I put it in parentheses or not? No,
Technically, since C is 0, it's almost like you already distributed, because anything times 0 is 0. So if you distribute within the parentheses and use the second equation that you have, like if you use...
So you're saying this is the correct answer?
Yes, because if you distribute within the parentheses, 0 times anything is 0. So you just got that.
Does that make sense? Okay. And you all did that automatically. You didn't even think about that until I heard it, right? Okay. What? Still with it. Okay. Yes.
Okay, so if we have something that's like there's a 2 outside the parentheses, and there's a C, do we put all of that in the parentheses? Or do we like 2?
No, if you have plus 0 out here, you would close your parenthesis out here. If there's not a C,
So what if there is a C?
well then your parentheses are closed after the C. That's how the equation is designed. And if there isn't a C, you should still close. You gotta close. The calculator will automatically give you that one. So you gotta close one of them. So you gotta close it after that, and then do your plus whatever, because that's separate from that's the up. Okay, now if you grab, just to double check, if that doesn't always make sense, remember you could graph this 15, and I'm not really gonna pi over 28, hopefully x. I think that'll work. All right, I don't know what okay, it'll be good. All right, now I could use it's gonna get cut off, but I think, I'm just trying to do this quick and it's not working. Come on. Okay, I need to accommodate 7, so I'm gonna go to, let's say, to 28. That way I'll get the whole curve, okay? But not 28 there, 28 here. Okay. And then I need to get up to 15, right? So -1, just so I can see okay. So that would be what the curve looks like. What the heck? Why? What am I doing? Did I not? I'm trying to put X in there, but did I not do it? 15 sine of pi over 28x, right? Is that what I'm doing? But I did that because I didn't want to make my goofy fraction. Jeez. Sine pi 28x. Okay. I just was trying not to. That's it. Okay. I was trying not to do that fraction, and that's why I put the parentheses in, but I apparently didn't like it. Yes.
So B.
Correct. Correct. B would have to, according to the calculator, and that's a good point to mention here. Your calculator, when you put in, sine, it throws the calculator, the parentheses right up there. So you're going to have to, when you want to check your work, you're going to have to put B inside there. Okay? You cannot not do it. All right? Yes?
If you had a C there and you didn't want to, and you had something complex like pi over 28, and you didn't want to automatically divide to get your base change as C, to simplify C, could you put it in the calculator since it gives you that parentheses? Would you use a double parentheses or a bracket to create?
Okay. I thought I was going to listen, but I really didn't listen. So I got to try it again. But anyway, I did this, and look, that's what it's supposed to be, okay? All right. Sorry, Melanie. Try it again. I will listen this time, I promise.
If you had a C,
Okay.
and since pi over 28 is a really complex fraction to divide C by so that you can simplify the equation, would you use double parentheses when graphing?
Yes. Yes, you would. You have to have a double, because this one will show, the calculator, that's an excellent question, I'm glad I listened that time. The calculator will automatically throw that one in there for you. That's not the one you want. So when you, you'll have to put 5 or 28 here, okay? And you saw what it did when it didn't like my pi over 28, so make the good fraction, and then do x minus, whatever, you'll have to do double parentheses.
If you do it that way, with the double parentheses, you don't have to change C to equal.
Correct, correct, because it's distributed, you don't have to distribute it out, good point.
And then if you had D, just click out of the parentheses.
You would just add it, yes, yes. Okay, good questions, girls. Any more? Sorry. I'll listen, I promise. All right, okay, now, this is where they get kind of dicey, but what's good about these is you're like, wow, I never really thought about, you'll be going to the beach thinking about sinusoidal curves. Sure you will. Okay, this is not a beach, but there is one that's a wave, and now, some are more difficult than others. This is probably where I maybe through it. So, let's adjust our homework a little bit, shall we? Because I don't want to crush this. This is here. Let me shut this